Today, basically, I will be talking about the sustainability, and we'll be talking from an ICT perspective. And how do we translate or walk the talk? How do we translate the sustainability initiatives into solutions and into projects that we can implement together for our customers? Before I go there, of course, when we are talking about the Paris Agreement, that was the first and biggest official agreement among countries to come to the net zero carbon. And I want to start by explaining, so going back to the basics so that I can come to the story of what I want to tell. So what does it mean, net zero carbon, and why? So first, net zero carbon means that the amount of carbon we produce is equal to amount of carbon we absorb, on Earth, right? So of course we produce carbon from all the machinery and industry, manufacturing and different industries, cars, transportation, buildings. In the UAE report says that 80% of the energy consumption goes to the buildings, from the construction to the operation and running of the buildings. So huge amount of carbon is actually produced from the buildings, and I will come back to this point. But this is from the emission point of view. From fixing carbon or absorbing carbon, there are only 3 elements on Earth that absorb carbon. One is soil, second is oceans, and third is forests. So if we look at it, it is completely it's completely neutral. Yeah? So in a sense that we cannot create oceans, we cannot create soil, but of course we can expand on the forests, right? So that's how we absorb or reduce the carbon. So in the other hand, how do we reduce the emission of carbon? Of course, that goes to the technology, and this is exactly the point I want to go to. So we cannot really produce or create something to absorb carbon except the forests, but we can do a lot from a technology point of view to reduce the emission of carbon. Now, it is said that in the Paris Agreement that they need to go back to the pre-industrial revolution. So industrial revolutions 1, 2, 3, and 4 started in the 1700s. So when they are talking about 1.5 degrees or 2 degrees below the pre-industrial revolution, that's the level that they want to find out what was the temperature at that time, and then we need to be maximum 1.5 degrees above that level. But the challenge is we don't know what was the temperature back then. It was not really measured, and there are no records to show what was the temperature. But to give you a feeling, from the late 19th century till date, there is an increase in the temperature by 1 degree. So in the last, let's say, 30, 40 degrees, there is already an increase with 1 degree. So some scientists are saying we need to go back. Okay, so from the beginning of the 19th century, we're able to measure and record the temperature. So some scientists are saying, okay, we cannot go back, so let's take this as the base, and then the 1.5 degrees max has to be based on that. Some other scientists are saying, no, we can do a simulation and find out what was the temperature back then, and that has to be the base for the measure. So the point I'm trying to make is, while there is an agreement that we should not go above the 1.5 maximum to 2 should be below 2 degrees, we don't know what is the base till date. So the base till date is not agreed between the 196 countries agreed or signed for the Paris Agreement in the NDC, which I will not talk about because Krishna already mentioned about it. The other challenge is the change in the temperature is not happening only because of the carbon emission. If there was no industrial revolution, the temperature would have changed as well. Why? Because they are classified into 2 factors, what they call it the external factors, and the other one is the internal factors. External factors, some example is the amount of heat we get from the sun. And that depends on the number of the sunspots. So the more you have of that, the more heat you will have into the earth. The less you will have from that. Another external factor is the volcanoes. When you have the volcanoes, these parcels that goes into the sky make a level of isolation for the sun to reach to the earth. And that makes the earth to become cooler, right? So it reduces the temperature, opposite to the previous one. Some internal factors is the transfer of heat between the oceans and the atmosphere. So the point is there are some other factors that are impacting the temperature of Earth regardless of the Industrial Revolution or not. So all these aspects needs to be looked at when you are finding what is the solution, what is it that we need to do. Why do we need to do that, and why do we need to fix this? So as one of the previous presenters mentioned, if we continue to do what we do, we will not have enough resources, natural resources, for the future generations. That's one. Second, we see with the change in the weather, the change happening in our life as well. We see more floods, we see reduction in the agriculture industry production, we see lack of water, we see an increase in the sea level, which could destroy complete cities in the future. So there are very good reasons why do we need to go for the net zero carbon. Now, having said that, and the conclusion of that, there are areas that we can work at and change, and there are areas that we cannot work at and we cannot change. And it is said, and I want to share this piece of information with you as well, it is said that there is no sink or tank that can absorb carbon. As I told you, there are only 3 natural ways to absorb carbon, but I have seen a group of architects in a startup in one of the exhibitions in Dubai a couple of months back. They created a facade for the buildings, and this facade is actually very tiny tanks of algae. So it is water, seawater, and inside there is algae, and it is very tiny ones, and it comes in blocks, and they connect these blocks, and they make the facade of the building. They actually designed that for a museum. What is the secret in that? The secret is the algae actually absorbs 30% of the carbon on Earth. This was a real piece of information that I learned. 30% of the carbon on Earth is absorbed only by the algae or microalgae. 70% of the oxygen on Earth is produced by the microalgae. So the initiative from this startup is actually to build this facade and grow up this microalgae inside the facade. So whatever power you consume or emission you will have in the building while the construction throughout the operation will be compensated. The carbon will be absorbed by the microalgae in the same building, and you will have more oxygen. I think for hospitals and other similar environment, that will be of a very big value. But coming to the other fact is that this is the only thing we can do, right? We can expand in the forest or try to help the microalgae to grow in different ways, but it is all created by God, if you want. There is no artificial solution that we can do in there to absorb the carbon. What we can do is that we have to leverage on the technology to reduce the carbon emission and be careful on what we consume, like what we mentioned also by Sajid and some other presenters. So 3 areas we look at. The first part is in the current products. Organizations like Huawei and others, everyone is putting the effort to make sure that we have what we call green products. So in most of the products we do today from the design phase, we make sure not only that we deal with green suppliers who are meeting the standard of sustainability, but we also make sure that the power consumption in every product we make is going to consume less power, and the threshold we have is minimum of 30%. The second is that we build different solutions for the different industries. Remember, it goes back to the industrial revolutions, and hence the consumption of power in different industries and the amount of emission needs to go down. So we work with the different industry verticals as part of an ecosystem, including consultants and others, to build solutions that will reduce the amount of emission, will reduce the power consumption to help these environments. Just to give you an example, if you are talking about in the oil and gas industry, or if you are talking about the telecommunication industry, and you have remote areas, you have what's called site power. So when you build the site power, first you need to think of what can I get from the wind, or how much solar panels and solar energy I can create. Then you connect that to different other sources. It could be the grid, the national grid itself, and then you have the inverter, and the inverter is using AI, like mentioned by other speakers, to find out how much capacity I have in the storage, and if I have enough, then I consume from the storage. If not, then what is available for me now? Is it solar or is it wind? And what is more cost effective for me to consume before the other one, and so on. And hence, end of the day, for this solution, it will be very efficient using the minimum emission and the lowest cost that will give you the maximum performance for the side power. This is just one example, but of course, examples goes on. The third stage of that is the continuous innovation. So definitely, this is a non-stop journey. We have to continue to innovate to make sure that we are coming up every day with new solutions that will reduce the emission and will enhance the utilization. This is a very relative to the audience solution that I wanted to share, is what we call net zero campus. The campus could be a university, could be a hospital, could be a government site, could be an airport, and we managed to build campuses that are actually net zero already today. So how did we do that? That's the solution, or that's the concept I want to discuss with you, and I will give you some names and references in the UAE and globally as well. So basically what we look at is that we look at the different technologies and solutions we are using. So it is not only that you are going to use a green product that is consuming less power of 30% compared to the competition or compared even to your previous own product, but how do you architect the entire campus to make sure that you are using even less power? And you will see in the coming example that we reach the scenarios of 60% less power consumption in a campus, right? It is, of course, very difficult to say I come to 100%, but again, I will give you scenarios, how did we come to 100%? In some campuses, you will have the net zero because you will compensate having some trees and planting around or inside the campus, depending on the size of the campus, and that will compensate as well for the amount, because this will absorb carbon, that will absorb or balance the amount of emission that you may have to come to the net zero. These are some references. So I start from Abu Dhabi. So Masdar MC2 is one of the buildings that will be the first net zero carbon building in the UAE or in Abu Dhabi. The second one is the Al Shara'a building. This is the DIWA headquarters. That's again a net zero carbon building in the UAE. The third one actually is in China. And in there, actually, we started in different phases. So we started by the smart campus, actually safe campus before being smart. Then we looked at the energy part, and then we came to the net zero. Of course, the area there is very big, as maybe you can see from the screen. So the number of trees planted to compensate for what you are getting as emission is also there. So the net of this one is 5,600 tons of carbon emission saving per year, 85% share of clean energy, 100% share of electricity. So the final product you are receiving is electricity in the form of 220 volts. And then electricity per year is around 3 million kilowatts. So of course there are tools and there are frameworks that can measure the amount of carbon your systems are producing, and the saving and the amount of kilowatts of electricity or clean energy also you are generating. Okay, so coming to the next level, which is how do we do it? So that's what we have done based on the technology and leveraging the solution. This kind of solutions is available, and I'm just picking one technology here to make it easy. And we have here in our stand some of these solutions shared if you want to go into some details. So one of the solutions we are providing, as well as a unique technology, is having fiber everywhere if you want. So FTTO, that's fiber to office, and then fiber to machine, single fiber for the entire campus. And we are talking also about sensing fiber, and they have one slide at the end to explain that. But the concept here is that replacing the traditional UTB cabling using copper and replacing that with fiber, and having multiple connectivity if you want on one, and having even the power required on the same fiber cable can save a lot of money, and I will share that in the coming slide, a lot of effort, and can help you convert to green campus. This is the fiber to office example, and I want to emphasize on the solution from an architecture point of view. You will end having zero ELV equipment room, and the power consumption saving is around 60%. Of course, the first question will come to mind, and then what is the cost? So I would expect that the cost will be higher. Actually, the total cost of ownership goes down by almost 30%. So the point I'm trying to make is, sometimes you have a lot of very good innovation, but commercially it is not viable, yeah? Because then you cannot commercialize the product, or it will be very expensive, or it cannot compete, or you cannot implement for any other reason. The point is, these technologies are implemented, and this is the outcome of having this technology implemented, including saving cost and time as well, and as we will see in the coming slides. The one point here I want to share is that when you are implementing the fiber and comparing it to the other technologies, you will see the comparison, how much power saving you will have using this fiber or all fiber technology. This is fiber to the room, so if we're talking about hotels or buildings and you want to implement the same, that also can be done, and again, the amount of saving in cost, time, and energy will be very high. Again, I'm trying to give very practical examples that are relative to the industry we are talking about, where it is implemented and what is the saving that we are talking about. All right, so this is the do-it-yourself, so that's how you implement it as well, because again, sometimes it goes to the mind. I'm sure we have some experts in the room, but for the rest of the audience, it might come to the mind that deploying fiber is difficult and requires special machines, and I need to have these technicians and that engineering. Actually, it is not. It's a very simple tool. The way we developed it, it's a very simple tool that you can buy yourself, and any technician or any person with a normal general experience can deploy it himself. So that's very easy to do, and that's part of the saving, if you want. So the implementation, the civil work, does not require any ducts, does not require any benching in the wall. None of this is required for the technology. Okay, so the sensing one, I want to give one example before we go to Moro. So basically, for the fiber itself, again, talking about the saving and the impact of the saving on the emission, if you have an airport or a government entity or any area that's sensitive by nature, traditionally people will have, organizations will have patrolling going in cars around the building and the airport. Then it was developed to use drones to monitor the borders of the airports and these buildings. Today, actually, you don't need to have that. You can just have a fiber cable going around the building, and then with the machine learning software in the cloud, if any intrusion happen, then the fiber will be able to detect that there is an intrusion, and it will tell you where is the intrusion, at what kind of intrusion. Is it a car or a person or an animal or whatever it is? That all goes based on the machine learning. So the amount of saving is very big, and again, that's one of the technology solutions when we are talking about the power saving and energy saving. The other very good reference I want to share is the Moro Hub. So Moro Hub is actually it is the first data center worldwide and in the region that's 100% green energy. Usually reaching to 100% is very difficult, but in the case of Moro, it is 100% green energy. How did we do it? Basically using the technology I mentioned, but still there is power consumption. The source of power that they take it from His Highness Sheikh Mohammed bin Rashid solar farm. So the supply of the power itself is coming from a green energy, and minimum consumption in the data center, which ends to be 100% green data center and the first in the region. This is another case. This is the Dubai Creek Harbor, the EMR. I heard some of the EMR colleagues are in the room. And this is the measure of amount of saving that we have done. So 130,000 kilowatts of consumption is reduced using the technology we have mentioned, and 62 ton of carbon emission is also reduced. So I'm just trying to put your hands on some facts that the technology exists, the design of the solution exists that can help you really to move to zero carbon and provide the solutions you do. And at the same time, you can save money. It is not complex and it is not very difficult or more expensive to convert to net zero or to start to go through the cycles for transforming your industry and your business to net zero. This is the end of my presentation. I thank you very much and I wish you a great day. Thank you.